Hi everyone, today I brought a very nice question based on the topic of kinematics. So the question is something like this. This is a triangle of side A, equilateral triangle, and at the corners of this triangle there are three particles. You can think of three insects. Now these insects are moving in such a way that A always approaches towards B. So wherever is B, A will be moving towards B. And wherever is C, B will be moving towards C, and wherever is A, C will be approaching or moving towards A. Okay, and the speed with which they move is same for all the three insects. It's the same speed, and that speed is constant. Please keep that in mind. Now, the first part of the question is at what time these three particles will meet? At what time they will meet? And the second one, which is very interesting, is what is the equation of the path which they will move, or the equation of the trajectory in which these particles or insects move. Now, why will these particles meet first of all? Because some of you may think this A is going this side, right? A is going here, B is going here, C is going here. So why will they meet? So many students get confused regarding this. A approaches towards B, right? So right now B is here. So A is coming towards B with a constant speed V. So after some time A will be here, covering some distance. B will cover same distance. Why same distance? Because speed is same. So in same time you will cover same distance. And C will also approach towards A and therefore cover a same distance. That means after some time A is no longer here. A is here now, right? And B is no longer here. B is here. And C is here, right? So next moment now A will not continue here because now B is here. And the question said A always moves towards wherever is B. So now since B is here, A will move towards B in this direction, right? So A will now move this side, covering a small distance. And B will move towards C. So C is here, remember. So B will be somewhere here, covering a small distance. And C, remember A was here at that moment. So C will move a small distance this side, which means now C is here and A is here and B is here, right? So now since B is here, A will now move this way, right? Wherever is B, and B will move wherever there is C, and C will move wherever there is A, right? So next moment A will be here, B will be here, C will be here. So again A will move towards this B, B will move towards this C, and C will move towards this new position of A. So can you see that A is not going straight like this, A is going in this curved path, right? Similarly B is going in this curved path and C is going in this curved path. So I hope now you are understanding that as time goes, this triangle starts rotating, but still this triangle, you can see all these dotted lines are still equilateral triangle because they all cover same distance, right? So eventually they all will meet where? Because they are traveling with constant speed, they all will cover same distance, and therefore whenever they meet, they all have to cover same distance from their starting point. And therefore the point where all of them will meet has to be the center, which is called the centroid. So A will travel this path, B will travel this path, and C will travel this path. And that is how the three particles will meet at this point, which is the centroid. Let me call this point as O. Okay. Now we understood that these three particles are moving in a complicated path and they are all meeting at the centroid. But how do we find the time taken for all these three particles to meet? Well, at the initial moment, which I will call time 0, A is moving towards B is moving towards C, and C is moving towards A, right? With speed V. Now, if you consider the line joining A and B, which I may show you separately here, the velocity of A is in this direction and the speed is V. So, the speed of A is along this line and the speed of B is at an angle 60 degree with the line joining A and B, right? Because this is equilateral, right? So this is the initial moment. Now after some time A will be here, we discussed, right? A will be here, B will be now here, and C will be now here. So now the new triangle will also be equilateral, but it will be turned with respect to the initial triangle. It has turned, right? But it's still equilateral triangle. Now this A will approach this B and speed is constant now also, right? And here also speed is constant. So this is V and this is also V approaching towards A. So if you now consider the new line AB, let me draw it here. So even now the speed of A is along the line joining A and B, and the speed of V is even now at 60 degree with the line A and B. Why 60 degree again? Because this is also equilateral triangle, because they all cover same distance. So, but one thing you may have noticed that this line now is shorter compared to the original line, isn't it? So next moment if you further wait, A will be here, right? And B will be here and your C will be here. So this is your new position of B, this is your new position of C. So now this is the line joining A and B now, isn't it? It's because this is the new position of A and this is the new position of B. And even now this will be an equilateral triangle if I have drawn properly. I may have done some small errors while drawing the diagram, but if I draw properly, this will be also an equilateral triangle. So now AB has become even more shorter. But one thing still remains same. And what is that thing? Even now the speed of A is towards B. The direction of the velocity of A is still towards B. And the speed is constant. And B will even now make 60 degree with this line. So eventually I hope you can notice that this distance AB is becoming shorter and finally when A and B will meet, that distance will become 0, right? Now how will this help us to find the time taken? Well, imagine you are here, this is you, and your friend is at a distance A. This is your friend, F for friend, okay? Now imagine your friend is, you are fixed, okay, you are at rest. And your friend is moving in a circular path around you. Suppose. Do you think your friend will meet you, or do you think you both will meet if your friend moves in a circular path? No. Why no? Because your friend will have speed in a direction tangent to this circle. and this velocity has no component in this direction, right? So this velocity has no role in this direction, because if you consider this as x-axis, this will be y-axis, they are perpendicular. And a vector along x-axis has no component along y-axis. So this velocity has no component this side. So there is no motion of your friend in this direction. Therefore, this distance will not change. Later, when your friend is here, again his velocity is perpendicular. So again this velocity has no component this side. So again this distance will not change. Later, when your friend is here, his velocity or her velocity will be along the tangent, and tangent is perpendicular to radius. From school geometry we know. And again this velocity has no component this side, right? So your friend will not approach you, and therefore you both will never meet. Okay, now think that you are at rest here like before, and this time your friend has velocity not only perpendicular to this line, but it also has a component of velocity in this direction. Let's take some example. Let's say this velocity component is 2 meter per second and this component is 1 meter per second. Okay, and this original distance between you and your friend is, let's say, 10 meter. Now, what will happen next moment? Will your friend go in a circle this time? No, because this time this velocity is also there. Your friend has velocity in this direction also. And therefore, next moment when your friend may be somewhere here, because resultant velocity of your friend will be here, right? Because these are the components of your friend's velocity. If one component is here, one component is here, the actual velocity will be here, right? That is the resultant velocity of your friend. So your friend will be somewhere here. And suppose I say that even now your friend continues to move in the same way like before. Which way? Well, even now your friend goes 1 meter per second perpendicular to this line, and here 2 meter per second. So in this direction, your friend has a constant speed, let's say 2 meter per second. Now, why this distance became shorter? Because your friend is having some velocity this side. So in 1 second, by the time, let's say, your friend reached here, in 1 second, this is at time 0 seconds, this is at 1 second. Remember, this distance was 10 meter per second and this speed is 2 meter per second. So in 1 second, your friend will come nearer to you by 2 meters, right? What is the meaning of 2 meter per second? It means in 1 second, your friend covers 2 meter. So if your friend covered 2 meter, then it means this distance now will be how many meters? 8. Why 8? Because original was 10 and this side your friend came 2 meters in 1 second. So this distance is now 8. Now later, let's say your friend continues to do the same thing I told. So this 2 meter per second will decrease this distance from 8 to how many meters now? 6, right? So later your friend may be here. The resultant of these two velocity will be somewhere here. So even now your friend does the same thing. Here 1 meter per second and here 2 meter per second. And this distance now will be how much? Well, it was 8. He moved 2 meter closer. So now this distance will be 6. Right? What this 1 meter, does this 1 meter per second contribute in this direction? No, I told you this velocity has no component in this direction. This velocity has no role in this direction. This velocity is only helping the friend to turn. Which velocity is bringing your friend closer to you? It is this velocity. And if it is always 2 meter per second, 2 meter per second towards you, then I hope you will understand that by the time your friend reaches you, the distance will become 0. So can you imagine that after 5 seconds, your friend will reach you? Because in 5 seconds, if your friend has speed 2 meter per second in this direction, then in 5 seconds, your friend will cover 10 meters, which means your friend will finally reach you. So the time taken would be this distance, which is 10 meters, divided by speed in this direction, okay, along this line, which is 2 meter per second. And therefore that would be 5 seconds. So please understand, this distance is 10 meters. So if I say the original distance was A, and if I say the speed in this direction along the line joining the two of you is 2 meter per second. So let me call that speed as V along the line between your friend and you. So between your friend and you. So this velocity is 2 meter per second. Okay. So this would be the time taken. So this is how you would find the time taken. Obviously that doesn't mean your friend came straight to you. Your friend kept going like this, like this, like this, and finally it must have reached somewhere here. Yes or no? And why it is turning? Because it always has this 1 meter per second also, isn't it? Okay. Now, in the case of your friend and you, remember you were at rest and only your friend was moving. But here both A and B are moving, right? With respect to ground, when you see from ground, you see both are moving. So it makes the problem little complicated. So we will make use of relative motion. So what does relative motion say? Relative motion says that if a body has velocity VA with respect to ground and another body has velocity VB with respect to ground, then if you observe this person or if this car observes this car, then velocity of B with respect to A will be VB minus VA, which simply means VB plus minus VA. And minus VA means what? Reverse of VA. So, if you are traveling with 10 meter per second and your friend is traveling with 20 meter per second, this is you and this is your friend, then for you, what will be your friend's velocity? Friend's velocity with respect to you. It will be friend's velocity 20 minus your velocity, which is 10. So that will be 10 meter per second. And how to find this in a direct way? So remember, to find velocity of B with respect to A, you have to reverse the velocity of A. Reverse minus VA matlab opposite of this, right? This is VA, right? This is VA. So minus VA means this opposite. So reverse this VA, add with VB. So if you want velocity of friend with respect to you, so in your frame of reference, you will be at rest, remember. So in your frame of reference, you will be at rest. If you are driving the car is at rest for you, right? Other things are moving in opposite direction. But for you, you are always at rest. So in your frame of reference, you will be at rest. And to find the velocity of your friend, you have to add to your friend's velocity the reverse of your velocity, which is opposite of this 10 is minus 10 here. And therefore, if you add these two, you will get 10 meter per second this side, because this 20 is more than this 10, right? So for you, if I find the resultant of these two velocities, 20 here, 10 here. So total will be 10 this side. So this is how you will see your friend moving. Okay. So that's the simplest idea of relative motion. So when two things are moving and you find the motion is complicated from ground frame, you sit in one of the particles frame. Then that particle will be at rest for you. But to find the velocity of other particle, what you should do? Reverse your own velocity which you have with respect to ground. Reverse that velocity and add with the other particle's velocity. Okay. So now let's come back to our original question. A and B, right? So A was always moving towards B with speed V, and B is always moving at 60° with this line. Okay, so that situation is same in every case. So as time goes, your triangle may become smaller and smaller, but A moving towards B, that remains same every time, and B moving at 60° remains same every time. Okay. So let us say now this B is U. So I am writing B as U and A as your friend, just to compare it with our previous concept. So now I want you to come to rest. So if I want you to be at rest, then I have to do the problem in the frame of B or in the frame of yours. So with respect to you, we want to solve the problem. So with respect to B, in B's frame, B will be at rest. And what will be A's velocity? Well, we have to reverse this velocity and add here. So before reversing this velocity, let's take components of your of B's velocity. So what are the components of B's velocity? Here it will be V cos 60, and here perpendicular will be V sin 60, right? This will be V by 2, cos 60 is half, and this will be root 3V by 2. So now you have to reverse these two velocities because we are doing with respect to B. So reverse these two components of velocity and add with A. So A's original speed was V before, right? Now if you reverse this V, it will become V by 2 this side only, right? And this, if you reverse, it will become here. This is root 3V by 2. Isn't it? So I hope this diagram is clear what I have done. Again, try to understand. This is the diagram with respect to ground. With respect to ground. I want to do it in the same way I did the friend and your problem. But in that problem, remember you were at rest, right? So to make U at rest or B, I have to go in B's frame. But B was actually moving. So if you go in B's frame, you have to reverse B's velocity and add with A's velocity. A's velocity was V already here. Reverse this component V by 2 this side and V root 3 by 2 this side. So these are the now velocities of A or your friend with respect to B or with respect to you. So let us further simplify this diagram. So this is the distance between you and your friend. In your frame of reference, you are at rest and your friend has a total velocity this side of how much? V and V by 2. So total of V and V by 2 in the same direction will be 3V by 2. And this velocity will be root 3V by 2. Now, as time goes, this distance becomes shorter because your friend is approaching you, right? So since your friend is approaching you, this distance will become shorter. But the conditions remain same, right? Even here, if you do the same thing, so this V, if you take components, right, and then reverse, so this will be V cos 60, reverse and add, so V plus V cos 60. Same thing, you will get 3V by 2 in this direction. Here also this V cos 60, here one perpendicular. So this problem now became exactly like that problem where your friend was approaching you with 2 meter per second constant speed and the original distance was 10 meter. And that time what was the time taken? I told 5 seconds. Remember? So here the time taken will be what? What is the original distance given? The original distance was A, right? Between A and B. Remember, right? The side of the triangle. And the speed in this direction. This is not important to make you come towards your friend. Remember, this velocity has no role in bringing you or your friend towards you. Remember. So therefore, we have to use only this velocity, which is 3V by 2. So time taken will be 2A by 3. So that's the answer of this question. The next question was to find the equation of the path followed by the three particles as they approach each other and meet at the centroid. So what is the equation of the path or equation of trajectory? Well, that question is usually asked in not your normal y and x coordinate system, but it is asked in the polar coordinate system. So let's try to understand what are these polar coordinates. So normally when you consider your coordinate system, we study x and y coordinate system, where if you are here, then this is your x coordinate and this is your y coordinate, right? And after some time when you go here, this will be your y coordinate and this will be your x coordinate, isn't it? So if I am able to give you y for every x, okay, meaning if for every x coordinate, if I am able to give you y coordinate, then I will know each position of the particle, in this case u. So if I know position of u at every moment, I can join those positions and that will give me the path. So when people say equation of path or equation of trajectory, what I should give you? I should give you y in terms of x. So y should be given as a function of x. So this equation, whatever it is equation of path. Right? In projectile motion, if you remember, the equation of path is y is equals to tan theta x minus some g by 2 u square cos square theta x square, right? We write as minus bx. So when you give y in terms of x, that is what is called the equation of path. But in this problem, we are going to give the equation of path not in terms of your y and x, but in terms of polar coordinates. So to give the polar coordinates, first you have to decide the origin from where you will measure the distance of the particle, and you have to decide one reference line. Okay, so just like x and y, you can choose anywhere you want. Origin and this reference line, you can choose anywhere you want. Now, or the question will tell you where to take. Okay, so let's say now the particle is here. So before we used to give you x coordinate and y coordinate, right? Now we will not give x and y, we will give this distance r. Now do you think if I give you only this distance r, you will know where is the particle? Do you think this r will define the position of the particle, exact position? No, because if I give you only r, you can be anywhere in this circle, isn't it? You can be anywhere in this circle, right? All these positions are at same distance r. So only knowing r will not let you know where is the particle. I should also give you angle made by this r with some reference line. So this angle let me call theta. So once I give you theta and r, then you will be able to know where is the particle. So just like if you know x and y, you know where is the position of the particle. Similarly, if you know r and theta, you know the position of the particle. So these two are called polar coordinates. Okay. So now we want to try to find the r in terms of theta. So r as a function of theta is what is called equation of path or equation of trajectory. So let's say our particle is here and after a small time it goes somewhere here. Okay, so the displacement of the particle would be this. So this is my, let's say, ds. Okay, so ds represents a small displacement. Now how can I write this in terms of my polar coordinates r and theta? So now if you notice, my r has become slightly longer. So this is my new r. So this r can be written r plus dr. And this angle also has slightly increased. So this angle is small angle. So d theta. Okay, so this is theta. So this small angle is d theta. Just like in normal calculus, we write if this is x, we write this small distance as dx. So if this is theta, a small change in theta can be written as d theta. Okay. So now let me imagine here an arc. So this is an arc of a circle like this. Okay. So for small displacement, this arc can be approximated as a straight line, remember, right? And you know from mathematics that if angle is theta, arc is s, radius is r or small r, then what is the relation between these three things? Angle is equals to arc length by radius. So arc will be angle into radius. So here this small distance, which is the arc length, don't confuse with this displacement, okay? This red color displacement is not the arc length, this is the small arc length. So this small arc length will be what? Radius is r and this small angle is d theta. So this small arc length will be r into d theta. So if I show this in a bigger diagram, it would be something like this. So this would be your ds, and this is r plus dr. So this is nothing but the extra r. Extra r here means the increase in the r, right? This is r. So if you go in this circle, this is also r, and this extra is your r plus dr, right? This is r. If I go in this circle, this is also r, and this extra part is dr. So this is dr, this is r d theta, right? And this is 90 degrees. So we can write ds is equals to root over dr square plus r d theta square. So this is how we can write small displacement in terms of polar coordinates, okay, r and theta. So first of all, we need to decide the origin and the reference line, right? So origin is here from where the distance will be measured. So the origin is chosen as the centroid where all the three particles ultimately meet. And the reference line is the line from the centroid to the vertex of the original triangle. Okay, so this was the initial position of A. So that line I have chosen as reference line. Now we already learned that our particle which starts this way will ultimately turn and come like this and it will meet here, right? That is what we learned. So at any moment of time, if I take at some time t, this is the position of my particle A, then this will be your r, right? And this will be your theta, isn't it? So this is your r from origin to the particle, and angle made by r with the reference line is theta. So we need to find r as a function of theta. So that equation is what we are looking for. So I have made this diagram into a bigger diagram here for clarity, okay? So as before, this is the reference line and this is the path followed by particle A as it approaches and reaches the centroid where all the three particles meet, remember. So we have to find equation of this path, which means we have to write r in terms of theta. Now one thing that is very important here is the velocity of the particle at any instant will be along the tangent. So this is the velocity, let's say. And that velocity, which is along the tangent to the path, will make what angle with this r? This is your r. Well, that angle, if you remember, is 30 degree. Now why it is 30 degree? Try to understand. Remember at the start, this was our triangle. A was here, right? And A was going towards B, and B was here, right? Initially, that's why A was going this side. And that time, this is your centroid, which is origin in our case, and this is your R, and therefore the angle made by velocity with this R line is 30 degree, right? Half of 60 degree. Now after some time, when A is here, B will be here. So A will come here and B will be this side and C will be directed this side. So now this will be your R line. But I told you even this is equilateral triangle. So when the particle A is now here, it will move towards this B. So velocity will be this side. So even now this velocity with this R, this is R now, right? Because R matlab what? Distance between particle and the origin. So before this black r and this black velocity v made 30 degree. Similarly here this red color velocity, if you can see, and this your red color r, the new r, will also be 60 degree because this is also equilateral. So that is very important, that the velocity of the particle A at any moment makes 30 degree with this r line. Okay, so later when the particle reaches here, this will be velocity, this will be r line, this angle will be also 30 degree. Okay, so this is the trajectory of the particle A as it approaches the centroid where all the three particles meet. When particle A is here, we learned that the velocity is making 30 degree with this r line. Okay, don't forget that part. Now, if you know that velocity is ds by dt, and ds represents a very small displacement. So in a small time dt, A will go somewhere here, A dash let me call. So this gap is your small displacement ds. So if velocity makes 30 degree with this line, ds will also make 30 degree with this line, isn't it? Now to derive the equation of trajectory, I need to show this part which is actually very small. I need to zoom it and show you. Okay, so I need to zoom this part, make it bigger and show you. So this is the trajectory, which let me show you this way, and this is A, and I'll show A dash here. Remember this line is your ds displacement, and with r line it makes an angle of 30 degree. So this is your r line. Okay, point O will be quite far now, because if you zoom this part, then this will become even more big, right? This is already big compared to this. If I zoom this part, this O will go very far. So O is quite far, you think. Okay, now let me make a circular arc here. So this is r, and let me take this dot line like this, and both of them will reach this point O. Okay, so very far. So then let me join these two. So this is like your circular arc, because this is r, this is also r, right? So this circular arc will be what? R into d theta, because this angle is your d theta, but here I have zoomed this part, so this angle is looking big, but it is only because I have zoomed this part, right? So please remember, this is A, this is A dash. Okay, A dash, and this is your d theta. So this arc length will be r into d theta. So this is r into d theta. This line will be what length? This is A dash. What will be this length? Well, this is r, this is also r, and this part is shorter than r. So this will be minus dr. But why have I put minus here? Well, that's very simple to understand. Whenever we write in calculus dr, d represents what? Change. And change means final value of r minus initial value. Now if you look carefully, initial value of r is this, final value is this dot line, and this centroid will be very far now because I have zoomed that part. That small part I have zoomed here, remember. So the bigger part will become even more big, right? So students, this length has to be positive, remember, but dr is negative. Why dr is negative? Because initial r was more than this final r. So if this is your initial r, this part is your final r up to the centroid. So final r is less, so dr becomes negative. But we want this length to be positive, but dr is negative, so negative will be positive. Okay, now how to connect this side with this side? Because this is, remember, straight, it is a circular arc, but it is a small part, right? So small part will look like straight line, I told. and this makes 30 degree with this line, and since these two lines are almost parallel, because this point now, this centroid now is like at infinity, okay, and if a point is at infinity, then parallel lines we know meet at infinity. So these two are almost parallel. So if this line and this line, if they are almost parallel, and this is the line, this red color line is here, and if this is 30 degree, this is also 30 degree. So this angle is also 30 degree. That is how you have to understand. So now we have done everything. So what will be tan 30 degree here? Opposite side of 30 degree is rd theta, and adjacent side is minus dr. Okay, this is like 90 degree approximately. So now we can, tan 30 degree is 1 by root 3. So r d theta by minus dr. So this is a differential equation which class 12 students can easily solve. Class 11 you may not have learned how to solve this, but let me try to show you how to do it. So to solve this kind of differential equations, we need to first separate the variables. So I can write dr by r, okay, cross multiply dr here, r here, and cross multiply root 3 there. So root 3 into d theta, of course minus sign, don't forget. Minus sign is important because you can see as angle increases, because your angle was measured from this line, right? This was your reference line, isn't it? So this was your theta and this was your d theta. So as the particle turns and approaches the centroid, theta is increasing, but your r is decreasing. So theta increases but r decreases. So minus sign is very important to show you that when theta increases, r decreases. So after separating the variables, we just need to integrate. Remember, theta is the angle made by this r line with this reference line, right? And initially, if you remember, our particle A started from here, and this was your origin, this was your reference line, right? And initially our particle was here itself at this corner. So this r line was this itself. So that time your theta was 0. So theta was 0 degree, and then it went up to some arbitrary theta which we have to find as a function, right? So we have to put some arbitrary angle, some unknown angle, and r value went from where to where? Well, r value, r is what? Distance of the particle from the centroid. So initially when the particle was here, your centroid was here, so this distance was how much? Well, I hope you know from school geometry that centroid divides the median in the ratio 2:1. So this distance, initial value of your r, which let me call it as r naught. So that distance should be 2/3 of this height, because centroid divides the median in the ratio 2:1. And height is how much? This height, this whole height, root over hypotenuse square was a minus adjacent here is a by 2, right? So a by 2 square will be a by 4. So 2 by 3 root over 4 LCM. 4a square minus a square, 3a square. So 2 by 3 root 3a by 2, 2 cancels, a by root 3. Okay. So the initial value of r when the particle was here initially from the centroid or the origin is root a by root 3. And after some time it becomes some arbitrary distance r. There is another way to find distance between centroid and corner, which is r naught. Okay, that is, just drop a perpendicular here, then this half is a by 2, half of the side, and this will be obviously 30 degree, this is 90 degree. So in this right angle triangle, this is adjacent, this is hypotenuse, so cos 30. So cos 30 is adjacent a by 2 divided by hypotenuse. Cos 30 is what? Root 3 by 2. So a by 2 r naught, 2 gets cancelled, cross multiply, r naught will be a by root 3. So this is another way of finding distance between corner and centroid, which is a by root 3. Okay. So now this is very simple for class 12 students, but for class 11 I'm not very sure whether you have done this kind of integration. So integral of 1 by x dx is log x. So integral of 1 by r dr will be log r base e, upper limit r, lower limit a by root 3 minus root 3, and this integral is obviously theta. Upper limit is theta, lower limit is 0, right? So now you have to put upper limit, so this will be log r base e minus log, put lower limit a by root 3 equal to minus root 3 theta. Now use the formula log a minus log b is log a by b. So this will be log of r by a by root 3 base e equal to minus root 3 theta. So this root 3 will go up, so log base e root 3 r by a minus root 3 theta. Now to write the final equation, you should know one more property of logarithm, which is if I write 2 power 3 is 8, then it means log 8 base 2 is 3. So similarly, if I write log 8 base 2 equal to 3, it means 2 power 3 is 8. So this is like your 8 here, right? So this 8 will be equal to base 2 power the right hand side 3. So this is like your 8, remember, log 8. So log this. So root 3 r by a will be equal to 2 power 3. 2 is the base. So here base is e power the number 3 on the right side, which is minus root 3 theta, right? So if you cross multiply, r will be a e power minus root 3 theta by root 3. So this is the equation of path, because I have given r in terms of theta finally, right? Now if I ask you for what value of theta r will be 0. So for what theta r is 0? For what theta r is 0? Well, the answer is only when theta is infinity, right? When theta is infinity, so when the angle turned is infinity, r will be a e power minus infinity by root 3, and then only e power minus infinity will be 0, because e power minus infinity means 1 by e power infinity, which is something power infinity is infinity because e is greater than 1, and that itself is 0. So r will be 0. R0 meaning what? The particle which will reach the centroid. So r will be 0. The particle will reach the centroid only after covering how much angle? Infinite angle. Meaning it will make infinite rotations before it reaches the centroid. So very interesting. So the angle covered is infinite, but time taken, if you remember, was not infinite. So think about this. How is it possible that angle covered is infinite but time taken is finite? Also try to think if there was any acceleration in this problem. Did the particles have acceleration in this problem? Try to answer and let me know. Okay.